Hello and welcome to the course Climate Hazards and Disaster Mitigation. Today we are going to discuss drought mitigation through nature-based solutions. So last time we understood the processes and chronological progression of drought propagation. We also discussed the characteristics and controlling factors of drought propagation and analyze the various drought propagation patterns. Today we are going to enlist the conventional drought mitigation measures. We'll understand the concept of nature-based solutions. We'll discuss different nature-based solutions, and finally we'll integrate nature-based solutions into sustainable drought risk management frameworks. Now, talking conventionally, drought mitigation, one of the primary things come into our mind is that we should increase our storage of rainfall. That is a way we augment our surface and groundwater resources. That is one of the way where we can mitigate droughts. Second way is we can improve our water use efficiency, that how efficiently we are utilizing our water, minimizing our wastages, so that we get proper utilization of our resources, and that can help when there is a unforeseen situation of a drought. So water harvesting and conservation processes refer to the processes and structures of rainfall and runoff collection from large catchment areas and channeling them for human consumption. So there are two widely used methods for water conservation. That is, one is the artificial recharge of groundwater, and second is a traditional method. So in artificial recharge, there is an extensive watershed development programs that are implemented. So we have in India also by Ministry of Jal Shakti, there is a Bhujal Yojana, where it is suggested to increase the groundwater levels in the areas or in the blocks which are significantly impacted by the groundwater depletion. Next is the traditional methods. Traditional methods of water collection and harvesting through ponds are more important for assuring continuous and reliable supply of water. In earlier eras, we were having lot of ponds and other structures like step wells, or we call bawdis in Hindi. So these structures were constructed to conserve the rainwater and use it in the lean period. Now both the above measures are low cost and community oriented and environmental friendly. So here are a few techniques for groundwater recharge. The first is contour cultivation. So if you are cultivating on the contours, the water goes from one contour to another, and their way it uplifts the soil moisture levels, and that helps in the groundwater rejuvenation. Then there are farm ponds. So these farm ponds, they are also used to store water, and if here in this figure it is shown an impervious sheet being placed, but if they are pervious in nature, they will also allow lot of infiltration. Injection wells. In injection wells, there is supply of water which is done artificially. That is, the water is pumped in the confined aquifer, and from that it will recharge the groundwater. Then there are percolation tanks. So these are more natural way of holding the water and then percolating it. Then there are check dams. So check dams, what they do, they create a temporary barrier. So on the upstream of the barrier, it allows sufficient time for the water to infiltrate and percolate, and the remaining water is taken downstream. The advantage of check dams is it controls soil erosion considerably, and it has been very successfully documented to elevate groundwater levels, particularly in the semi-arid regions. Talking about the traditional methods, you can see these are the jhalars or step wells which are documented here. You have talab or bandi, then you have bawdi, then you have taka, or which we call tank, then you have ahar pines, then you have johads, then you have khadin, and then you have panam keni. So these are some of the traditional methods which have been widely used across various regions in India. Next is rainwater harvesting, where we collect the water particularly on the rooftops which are in having a sufficient area. So these we refer to as a catchment area when we talk about rainwater harvesting. So this water is collected. Initially, when you are talking about rainwater harvesting, the first two waters we just pass it on. We do not take into the collection system because they contain lot of muds. So then that is called first flush. So we just pass that water, and the remaining water, we are collecting it to our underground storage by means of a filtering system. So we can use a natural filter of gravels and sand, so that will filter the water and it can be consumed for at least domestic use, and if there are more filtration techniques, it can be made portable as well. And last is water use, improving the water use efficiency by using drip and sprinkler methods compared to the traditional flooding methods. So they can improve the scenario of groundwater as well as surface water. Coming to nature-based solutions, so these nature-based solutions are defined to protect, conserve, restore, sustainably use and manage natural or modified terrestrial, freshwater, coastal and marine ecosystems that address social, economic and environmental challenges effectively and adaptively, while simultaneously providing human well-being, ecosystem services and resilience and biodiversity benefits. So it is a very exhaustive definition which primarily focuses on that it is an ecosystem based approach where we think on restoration, addressing a specific issue, creating relevant infrastructure, managing it and protecting the ecosystem. What are the societal challenges? Societal challenges are climate change. We have to also think on the whether it is sustainable or not, how to improve water efficiency, mitigation against disasters, whether it is environmental friendly or whether how it affects the human beings. So the human well-being and biodiversity benefits, they are the ultimate outcomes of applying NBS, so that our ecosystem is not degraded by any way and it becomes more and more inclusive. So NBS are relatively new and innovative approaches, and their implementation in drought risk management is still limited, and there are very few pilot studies which have been noticed rather than large scale implementation of them. So here you can see that in this infograph that there are more tree plantation, that is more afforestation measures, making more greener cities, protecting and restoring natural areas. So these are some of the NBS solutions which have been proposed, which have multiple benefits. Again, looking at this particular infograph, we can see that why NBS are important. So they align with the natural processes of the ecosystems, they benefit biodiversity, they are more adaptable, suiting them to the local conditions. So locally appropriate, you can do the solution. They are multifunctional and they overcome societal challenges and address human well-being. So these are the few things which make NBS more lucrative option. Coming to the fundamentals of green, grey and blue infrastructure. So starting with what is green infrastructure. So green infrastructure are only nature based solutions that you can think, where you can use vegetation and soil to manage water naturally. So in that way you improve the soil's ability to hold water, you reduce water loss from runoff, you recharge the groundwater, and you reduce the water demand. So natural ways how you can do that. So what are the natural or greener ways? You can plant more forests, there can be rain gardens, green roof and urban trees, so that you improve the biodiversity as well as the air quality. Next is the grey infrastructure. So grey infrastructure are more the engineered solutions. So there can be traditional or built system by humans. So it is more where the human impacts are considered, like dams, reservoirs, water treatment plants, pipelines, canals, desalination plants, whereby we apply engineered processes to improve the water storage and availability and reuse. So these grey infrastructure are expensive. To some extent they damage the ecosystems, and they are more rainfall dependent and also some cases demand driven. Next we have the blue infrastructure. So they are more water focused natural systems, like natural or semi-natural water systems. So examples are rivers, lakes, aquifers, floodplains, restored streams. So here we store and slowly release the water, we support groundwater recharge, we maintain water availability during the dry seasons as well. So these are some of the in terminologies which will be commonly used in NBS technology. Coming to the NBS for drought mitigation, so NBS are very crucial to achieve drought resilience by their ability to buffer direct ecosystem impacts, deliver several co-benefits, and complement other drought resilience measures like crop insurance, early warning systems, traditional engineering solutions. So for NBS, the benefits are created in two ways. First, it creates resilience of the system to cope up with the causes and consequences of climate change, and second, it supports biodiversity, and thereby the chain of ecosystem services will sustain human life. Now, integrating your NBS with commonly applied drought strategies like grey infrastructure will offer a very robust and adaptive approach to address water scarcity and land degradation. So we cannot eliminate this grey infrastructure because of this concretization and urbanization things. Grey infrastructure is becoming more and more relevant in these days. But how it can be blended with the green or blue infrastructure so that the ecosystem is less degraded and we derive multiple benefits and thrive upon the natural resources. So you can see that there are some NBS in this infograph which are proposed for both floods and droughts. So you can see that forestry, that is again this NBS is used for both flood and droughts in different ways. Artificial wetlands, then you have wetland restoration, then you have riparian restoration. So riparian refers to the right of those who are in the downstream. So if the river is coming from here and if I construct a dam here, so what will happen? All the water will be stored here. In that case, the downstream people will get very less water. So these people are called riparian. So they also have equal right over the water, and that is how their rights also should be restored and preserved. So if you create a dam upstream, then the benefit should transform to them as well. Then agriculture, best management practices, and other measures are there. So alongside the grey infrastructure, NBS ensures that short-term needs like soil stabilization and water storage are met, while long-term ecosystem functions are also regulated. So when we talk about NBS, they are not like very quick fix solutions. So they are long-term solutions. They will take time, but they will provide multiple social, economic, and biodiversity benefits. So we have to be very patient while evaluating the performance of NBS. Now NBS can be deployed at smaller local scale and can grow in scope and have enhanced benefits. Affected climate zones. So there have been some studies which have been documented on the use of NBS and particularly towards drought impacts and desertification. And what has been found that most studies are carried on the temperate region followed by the tropical region. Very few studies are there on the arid region, while Mediterranean and polar region they are less likely to be facing droughts, but arid region may have drought probability. So there is a larger need to explore the effectiveness of NBS over other regions as well. What are the types of NBS? The very first type of NBS is restoring natural or protected ecosystem using minimum interventions. So our intervention should be very minimum when we are trying to bring in this NBS plugins in our existing ecosystem services. Second is we should adopt effective management practices to reach sustainability and multifunctionality while gaining more selected ecosystem services. So our management should be more effective so that we get maximum benefits. And third type is we can have maximum intervention so that we create some new ecosystems and deliver key services. For example, in a particular region, you create altogether a new kind of ecosystem by creating a large wetland or creating a large urban forest. So that way you are altering the existing ecosystem in a very maximum way, and we can see what kind of response we get. So coming to some of the core principles of NBS, the very first principle of NBS is sustainability. So while applying NBS to any project, our primary goal should be that it should be long-term sustainable and resilient to the ecosystem. Now this not only involves that we should protect the natural habitats but also restore the degraded ones. So sustainable practices ensure that ecosystems can continue to provide vital services like clean air, clean water, even clean energy sources for our future generations. Second thing is, when we apply NBS, we should ensure that it is multifunctional. For example, if I plant a tree, what can be the functions? If I plant a fruit tree, I get, let us say, fruit as one byproduct, or I can get oxygen. But there can be multiple functions which can be delivered from that. For example, if I plant a bamboo tree, I can get bamboo as an engineered material. Then bamboo can be used as an edible material. Bamboo can also be used for various other purposes like handicraft. So it is a multifunctional thing. So whenever you think of an NBS, it should be of a multifunctional character. So for example, a single solution such as wetland restoration can provide flood control, improve water quality, enhance biodiversity and sequester carbon. So this makes NBS highly effective and cost efficient. Third is inclusiveness. The effective NBS engage local communities and stakeholders in the design, implementation and management. So everyone should be included when you are implementing the NBS. Also, we should ensure that we have tailor-made solutions for the local needs. We cannot copy paste solution from one place to another because local diversity and conditions will be different. So if we do that, it will ensure us long-term success. Community involvement is very important because it fosters a sense of ownership and responsibility towards the environment. If we own it, we'll be able to manage it better. Next is adaptability. NBS are inherently flexible and adaptable to changing environmental and social conditions. You can either scale up or scale down the NBS or make modifications as per the local needs. This adaptability is very crucial in face of unpredictable climate change and other dynamic factors like urbanization, industrialization and human interventions. Global applications of NBS. So from a study we have taken this where all NBS which are applied at a global scale except Europe. So you can see that the text size is proportional to the number of times it was applied. So afforestation is the highest NBS that is applied. Then comes wetland, then comes rainwater harvesting, green roof. Green roof is particularly more applicable in urban settings. Then you have river restoration. So these are some of the prominent NBS which have been applied in real world practice. So let us discuss a few of them. First is afforestation or reforestation. So afforestation and reforestation. So afforestation primarily means like a area which has been partially cut down and deforested, so you improve that. Okay, and reforestation is like you are coming up with a new forest land and strengthening the natural hydrological cycles. You are making catchments more resilient and to the drought effects. So when you are planning both afforestation and reforestation, you should be very mindful that you plant native tree species. So you cannot have like a pine tree you cannot plant in somewhere Gujarat or Madhya Pradesh because it is native to Himachal or Uttarakhand. So you have to be very mindful that you use the native species because when you make your areas more forested, it will improve your soil infiltration and groundwater recharge. It will also reduce the evapotranspiration losses by shading the soil and lowering the surface temperature. The canopies of the forest and the litter layers will enhance the organic content of the soil and its water holding capacity, and ultimately it stabilizes the stream flow generation and maintains base flow during the dry periods. Next is wetland restoration. So wetlands act as natural sponges which store excess rainfall and release water slowly during the dry spells. Wetlands are vital ecosystems that provide numerous benefits. So the first is improves the water quality. Second, it improves water availability. It enhances biodiversity by providing natural habitat for many species. It can be aquatic species or aviatory species. It can also help in flood protection by absorbing excess water during heavy rains. It can help in drought mitigation by storing that water and making it usable for the drought conditions. Also, they are very significant in carbon sequestration, which is helping mitigate climate change. It is also referred as blue carbon habitats, because water is sequestering lot of carbon from the atmosphere. And finally, it helps in preservation of riparian and floodplain wetlands by reducing the drought intensity and desertification risks. Next is agroforestry. It involves integrating trees in an agriculture landscape. So this can improve the soil health, increase crop yield, and enhance the biodiversity. Also, trees can sequester carbon. It can reduce the greenhouse gas emissions and provide additional sources of income to the farmers. If you have fruit trees, so they can harvest fruits or nuts or even timber. Practices like mulching, crop rotation and crop cover, which will reduce the evapotranspiration and improve the infiltration. Next is artificial recharge of groundwater. So this includes spreading and impounding water on the land to increase the infiltration and percolation to the aquifer, or it can also be done by injecting water directly into the wells. Usually that is done in case of confined aquifers. So confined aquifers, your two layers of impervious surface that is there, and between there is a pervious surface, so from where water can be stored. So that is a confined aquifer. Unconfined aquifer is a bottom impervious layer, top it is pervious layer. So as we all know, groundwater levels are declining across the country. So because our water withdrawals have exceeded the rate of recharge, and that is why we are facing such issues. So if we can create more recharge zones, which we can help to stabilize the base flow and reduce the hydrological drought risk. Next is rainwater harvesting. So this includes collection, storage and utilization of rainwater for various types like irrigation, groundwater recharge or domestic supply. So what it does, it preliminary stores rainwater, thereby it reduces surface runoff. It will also include benefits like improving infiltration, and groundwater recharge can also be some of the purpose. If you have a tank which is open at the bottom, it can augment the groundwater levels. It contributes to drought mitigation by enhancing local water availability and restoring hydrological balance. Overall, rainwater harvesting is a practical, low cost, local scale and ecosystem based strategy for mitigating drought impacts. Next is landscape restoration. It is defined as a holistic and standard approach to conserve and restore that generates environmental, biodiversity and socio-economic benefits. So in this, there are a lot of drivers of deforestation and land degradation which have to be addressed through comprehensive programs. Once we are able to recapture those lands and conserve them, it will help us in a large way to drought resilience. Also they align with NBS logic that we restore the ecosystem function so that we can have buffer against water scarcity rather than simply doing engineering measures to fix them. So here are two examples. On the left you can see that this is the image before intervention and this is after intervention. So what you can see that land shaping and soil amendments in a coal mine. So this is a coal mine. So you can see the land is totally degraded. So what they did in Rajasthan, so they planted 400 leguminous trees and shrubs per hectare to afforest this region. Then again the second one is a zinc mine. Again in Rajasthan you can see entire land is totally degraded. So they again used same technique on 24 hectares of the land, planted lot of trees and caused a large scale land stabilization. Next is a very interesting concept of spawn city. So it is usually pertaining to urban areas. So when you are talking in an urban setup, So how you can implement the hydro ecological infrastructure in an urban setup, that is called a spawn city. So it helps mitigate drought by using NBS to absorb, store and reuse rainwater and recharge groundwater to create a reserve for the drier periods. So by increasing permeable structures like green roofs, then rain gardens, permeable pavements, so there are pavements which will allow the water to percolate and recharge groundwater, so that your runoff can be managed more effectively than the drainage systems. So spawn cities are built for resilience against water shortages in the dry season, and thus they close the urban water loop. So we have some case studies about landscape restoration. So this is about Siddhi, a district in Madhya Pradesh, where landscape restoration was carried out. So watershed management practices were large scale applied. So farmers who once relied only on monsoon rain now grows crop all round the year because of improved water facilities, and which have elevated their income sources as well. Next is an example of Somalia, where in a pilot project they demonstrated how green infrastructure can be effective in fragile ecosystem conditions. So Somalia is mostly dry and arid land, so there sand dams were created where they act as natural cover that stores water beneath it and protects from evaporation. So this is a particularly new concept of sand dams. Compared to deep wells, which are costly to drill and maintain, sand dams offer low cost, low maintenance and more sustainable water source, and improves the resilience of the community towards drought. So you can see that here they have created a sand buffer over the water sources, so they can dig a bit and extract water very easily as compared to other engineered solutions. So key takeaways from today's lecture: we saw that NBS can integrate ecosystem conservation and restoration and help manage our resources more sustainably to build drought resilience. NBS complement grey infrastructure by providing adaptive, cost effective and long term drought mitigation solutions with through enhanced soil moisture, groundwater recharge and rejuvenating ecosystem health. And lastly, implementation must be of NBS must be context specific, considering spatial scale, local climatic conditions and community participation for the effective outcomes. So here's an activity for you: review at least 2 case studies where successful implementation of NBS for drought mitigation is demonstrated. So these are few additional references. Thank you, and in the next lecture we'll summarize drought severity and mitigation.